Hi guys, I'm Fera from Guitars AI, and I welcome you to this tutorial where we continue to explore the basics of musical instruments classification using machine learning. So this time we will continue using the male frequency capture coefficients as another feature, but we will use a different classifier, which is a support vector machine. So as usual, we import all the libraries we are going to use. This time I'm importing Pico because I want to save a vector of audio features of the MFCC, so we don't need to recalculate it all the time. We can save it and then load it. And I'm also using joblib, which is similar to Pico, but it's from scikit-learn, and it's a way also to save a trained model, so we don't need to train it all the time. So basically these are the two differences. And now I'm not importing the K and N, I'm importing the support vector classification library where we find inside the support vector machine algorithm. Yeah. So once again we use the same data set, so we will compare the results from using the support vector machine as a classifier compared to previous results where we achieved 5 mistakes out of 150 samples. So yeah, it's the same. We will get the files, prepare the labels from the file names, we encode the labels, we calculate the MFCC as an audio feature. So we go every sound sample and we calculate it. This is what we're doing here. We do this standardization, which we want our vectors to have zero mean and unit variance. And here is the first difference. So I'm saving the scaled feature vectors calculated here. I'm saving here and here. You can load it if it's already saved. So then we divide our data into a train set and a test set. We still have the same shapes, the same vector dimensions as before. And here starts the first difference, because we are going to use the SVM, support vector machine, instead of the K nearest neighbors classifier. So in very general terms, the support vector machine is an algorithm that will try to find a hyperplane in this high dimensional space of our features. That this hyperplane will divide the different classes with the maximum possible distance between the classes. So I recommend you to go through some documentation on Wikipedia, also the documentation in scikit-learn, which is the library we are going to use. So when we use the support vector machine, we have a choice of different parameters and different kernels. So for this example, I'm using the radial basis function as a kernel. There is other, you can use polynomials, and we have these two parameters, which I recommend you to understand what they mean in the scikit-learn documentation. And initially I guessed, so I had an initial guess starting point. And usually in many machine learning problems, you need to guess your initial points and then adjust different parameters until you reach better results. And then we do the same way like we did before with the K and N. Another difference here is that after you train your model, I'm saving, so we don't need to retrain it all the time. Then we predict the labels using the trained model, and we have the evaluation. So this time we achieved 99% accuracy. So the algorithm made just one mistake compared to 5 mistakes when we use the KNN. So everything is the same. The difference at this point is we're using a different classifier. See the confusion matrix. So there was a mistake. It's an oboe was classified as a trumpet. Yeah, that's it. I recommend to play around with different classifiers, different parameters, and check you later.